At the same thickness, kangaroo leather can be 3 times stronger than cowhide, and yet it's thin enough to wrap around a footballer's foot like a second skin. So how does a wild Australian animal end up as the secret weapon inside elite Nike boots and high-performance sports gear? Most people never see this process. They see the finished cleat on a shelf. They hear the marketing about touch, control, and comfort. But the real story starts thousands of kilometers away from any stadium in the Australian outback, with an animal that has been part of indigenous life for thousands of years and is now at the center of a tightly controlled industrial ecosystem. Before we head inside the factory, if you enjoy deep dives into how materials become power and profit, consider subscribing so you don't miss the next story. Kangaroo leather, often called K-leather, is not a gimmick. It's a very specific material with a very specific structure. Under a microscope, its fibers are highly organized and supported by a secondary mesh layer. The weave angle is low, the fat content is low, and the grain layer is thin. That combination is why, pound for pound, it's considered the strongest leather available at any given thickness. It can be shaved down to under a millimeter, stay supple, and still resist tearing when a player plants, twists, and sprints over and over again. Long before Nike or any sports brand discovered it, indigenous Australians were already working with kangaroo hides. They turned them into cloaks, loincloths, and bags. They used kangaroo sinew as thread for sewing and binding. This wasn't fashion. It was survival tech. Later, as European-style industries spread across the continent, that same strength and durability pushed kangaroo leather into more utilitarian roles: whips, harnesses, saddles, anything that had to endure tension, shock, and weather without failing. The modern sports industry came next. As football, rugby, and other high-impact sports professionalized, brands went hunting for materials that could deliver a new level of performance. Traditional cowhide was strong but heavy and thick. Synthetic uppers were light but often stiff, or they tore under stress. Kangaroo leather, with its unique fiber structure, solved that problem. It allowed manufacturers to build boots that were both ultra-thin and incredibly tough. That's how it became a top choice for high-performance athletic footwear, like cleats and other equipment, where grams matter and failure is not an option. But this is not a farmed animal. Kangaroos are harvested from the wild, and that changes everything about how the supply chain works. Australia considers kangaroos abundant, overabundant in some regions, so the harvest doubles as population control to protect ecosystems and agriculture. Only 4 species can be legally taken for commercial use: red kangaroos, eastern gray kangaroos, western gray kangaroos, and wallaroos. Licensed hunters operate under the National Code of Practice, a framework built on current science about kangaroo behavior and ecology. They must pass regular testing every 5 years to keep their license, with a focus on animal welfare standards and humane methods. Once a kangaroo is harvested, the hide is removed and quickly preserved. At this stage, it doesn't look like a luxury material. It's a rough triangular piece of skin about 3 feet long on each side, somewhere between 3 and 9 square feet in area, usually averaging 5 to 6 square feet. The thickness is typically in the 0.6 to 1.4 millimeter range, with many tanneries preferring the 0.7 to 0.9 millimeter band. The hides are salted or chilled, then shipped to specialized tanneries, where the transformation really begins. Inside the tannery, the first step is to strip away everything that isn't usable leather. The hides are soaked to rehydrate them, then limed to loosen hair and remaining tissue. Once cleaned, they're de-haired and fleshed, leaving a clean raw hide. From here, the tanning process stabilizes the collagen fibers so they won't rot and can withstand moisture, sweat, and heat. The exact chemistry can vary from tannery to tannery, but the goal is the same: lock in that natural fiber structure while allowing the final product to stay thin and flexible. After tanning, the hides are graded. This is where the future of each piece of leather is decided. Because kangaroos live in the wild, their skins tell a story. Scratches from scrub, scars from fights, scrapes from rock and brush. Holes are rare, but surface defects are common. Tanners and buyers look at each triangular hide and ask a simple question: how many flawless boot vamps or shoe uppers can we cut from this? A grade 1 hide yields at least 3 full sets with no defects in a center triangle about 3.5 feet on each side. Grade 2 still gives at least 3 sets, but with some minor issues. Grade 3 yields 2 sets, Grade 4 1 set, and Grade 5 maybe half a set. Most hides fall into Grades 3 and 4. Grade 1 and 2 are scarce, And that scarcity is one reason a top-tier kangaroo leather boot feels and costs the way it does. The best grades are reserved for the outside of products that must look and perform perfectly. The vamp of a Nike football boot, the upper of a high-end dress shoe, the visible panel of a glove. Lower grades don't go to waste. They become linings, internal reinforcements, or smaller leather goods where a scar can be hidden, or even used as a design feature. That efficiency matters when you're working with a wild resource and strict quotas. Almost every square inch that can be used is used. Once a hide is graded, it's split and shaped to the exact thickness demanded by the application. For elite cleats, that might be under a millimeter, allowing the player to feel the ball as if they were barefoot, but with enough tensile strength to withstand constant flexing and impact. The leather is then dyed, often drum-dyed, so the color penetrates deeply, and finished with coatings that can add water resistance, grip, or specific textures. For performance footwear, the finish has to walk a tightrope. It must protect the leather from sweat, rain, and abrasion without turning it into a stiff shell. That's where the natural low-fat content and fine grain of kangaroo leather help. It doesn't need heavy coatings to behave the way designers want. By the time a sheet of K-leather reaches a sports factory, it bears little resemblance to the raw hide that came off a wild animal. It's uniform, consistent, and engineered. Pattern cutters lay out the shapes of uppers and panels to maximize yield from each triangle. Machines punch, cut, and stitch. The kangaroo leather is often combined with synthetic meshes, foams, and modern sole units. Yet its role is still fundamental. Wrap the foot, transmit force, survive abuse. In a finished Nike boot, you might see only a logo and a colorway. Underneath, the leather's microstructure is doing silent work every time a player accelerates, changes direction, or strikes the ball. The real twist in this story is that the most advanced sports gear on Earth depends on an animal that has been part of Australian life for millennia, and on a material that is, at its core, ancient technology, leather. The science is new: fiber analysis, controlled thickness, performance testing. But the principle is old. Take a natural structure that evolution has refined for survival, respect its limits with tight regulations and ethical codes, and then push it right to the edge of what it can do. That's how a wild kangaroo becomes K-leather, and how K-leather becomes the quiet advantage inside some of the world's most coveted boots and tactical gear. If you want to understand how far this can go and how dark it can get, kangaroo leather is only half the picture. The crocodile leather industry takes the same logic of strength and luxury into far more controversial territory, from farmed reptiles to ultra-high-end fashion houses. That story completes the puzzle of how animal skins become status symbols and performance tools. See you there.